All right, everyone. So we are here to discuss about the sequel, its understanding, the significance, and what, as an analytics pro, we will go back and deliver. So, in the modern business world, if at all you are looking at it, we have a massive data coming up. Its availabilities, and the companies across the globe, they're all managing, they're churning out all the millions and the billions of data each day. Not just this, the big data is also a sensation these days, right? So it's a reasonable aptitude set to understand or know the given data in different fields we have, like your pharmaceutical fields, your business, be the education sector, or let it be a sports, anything, whatever you would like to look at it. So we order to understand how a data management can do in terms of your analytics with respect to your Power BI as well. When I say analytics, of course it is, and also including your SSRS. Now SQL has become an essential skill set all for your data analysts, data scientists, and whosoever are working on these analysis purposes, or let it be on the data. So what exactly is the SQL is helping us, and now let's find that out. So why do we need to SQL? So in case if at all you're looking at it now, these two persons are trying to communicate with each other. Now they have to use a certain language which is understood by both of them. So in case if at all you're listening to what I'm saying, the medium in between to both of us is English. So we are using English as a language barrier to communicate between both of us, to understand what I'm saying, to get what it is about. Now in a similar fashion, whenever you have a user trying to go back and write a SQL query, which hits the database and gets the output from there to the user who requested the data with. Now, it is organized collection of information in the form of tables, which is having different classes of data. Meaning, when you're talking about your SQL, it's always about the relational database management system, which is RDMS. Now, what is this RDMS? When you're trying to store the data in a tabular format, it is a relational database. If you do not store it in a tabular format, it is a non-relational database. Now, when you're trying to look after the structured query language, which is your SQL, and that's how it is abbreviated term. Now, that is kind of an authoritative database programming language. And we use this programming language to develop, to sustain, and to recover any relational databases which are online. So also despite being one of the older programming codes, SQL is very older, correct? Now it is still prevails the most comprehensive executed database languages within the market you have. Now when it comes to this, you can readily use the SQL. You can use it for transferring the data. You can organize the data. You can do a lot with respect to your relational database management system, which is your DBMS. Now it can comprise all your tables. It can pull the data within them, all the multiple files with extensive data tables. They can all get linked together with the help of your keys present between the tables and also your shared files. Now we use the SQL for that kind of purposes. Now let's see a few more details about the next steps. Is that to access and to manipulate the databases, dealing with all your relational database stuff, and query the language to communicate with the database. So this is the medium. This is the fundamental programming language which is required for us so that we can access the online databases which we have. Then what all we can do when you have SQL? We can execute the codes. Yes, SQL can execute all your queries against a database. Of course, you have seen we provided you a database over there within your Power BI stuff. What happened exactly after that? You were trying to pull few tables right from your database to your Power BI. And how do you do it if at all you would like to use a select statement? You're trying to execute the statements. You're trying to execute it with the help of your SQL Server Management Studio. You write a query, you execute it, and then you see the outputs. Retrieving a data from a database. You executed a query against a database, but you have to retrieve the data as well, right? So that is what it does for us too. Once you write the query, it will retrieve the data from the database. What else? Inserting new records in the database. So in a day in and a day out, you always have new data coming in picture. All the new data has to be updated within your SQL server. So inserting the records can be done. Now, not just inserting them, you need to also update them, right? So you have a typo error in the record which you have inserted. Now you need to update it in a different fashion now. So updating is also possible. It's like rewriting. You can also delete records from a database. Yes, not just inserting or updating. You can also delete anything if you don't want, if you see that there's something duplicate occurring. Then your databases. Yes, SQL also can create new databases for us and have multiple tables. So you have a database, then you are able to create new tables within that database. Now let's try to understand what it's about right now. See, I'm trying to get with a similar kind of an example which you have spoke about it earlier, but let me reiterate it. I want you to think your school or a college as if it's a SQL server. Now within each SQL server you have like multiple colleges, right? So college is one of your SQL server. Now within your college you have multiple branches like ECE, Triple E, CSE, and so on. Now these branches are nothing but your tables, your databases. I want you to consider them as a database. Each class is a database. Now ECE is a database, that's fine. Now within these databases, what do you have? Within ECE, you have tables, which are your benches where people used to sit in them. You have a lot of tables over there. Now within those database, you have tables as well. And within these tables, you see records, and in college, you see within the tables, people are the ones who are sitting in them. So understand the hierarchy here. Server, database, tables, records. So this is the kind of the hierarchy you will have in your SQL. Then we have the stored procedures. Now we use these stored procedures to create in a database where we can go back and use them in such a fashion. Let us suppose now you would like to create your own table. You don't want to write a query, or you do not want to uh, execute a query in a similar thing in a multiple times. So what is the best bet of doing it? So when you're trying to use a stored procedure, it is like it can have all your access of your relational database management system, which is your RDMS under your SQL that is well known. Now these procedures, the stored procedures, they were also getting stored in another of your database like a data dictionary. We use them for data validations, and we use them to or to have an access control mechanisms all over your records which has been provided. Then let's talk about a view. Now, whenever you write a query, you get a result, that's all fine. But this kind of the views, it's like, it will temporarily store the query rather than the stored procedure. So when you have a stored procedures created, they will have the tables added in your SQL server. But when you have a view, it will execute it. It will show you the result only on the fly, and it does not contain any data being stored anywhere else. Meaning it is just like your calculated column and a measure in your Power BI. Measure will only show you the results on the fly, but a calculated column has to store the data in a column wise. Now that is the kind of the difference between your stored procedures and a view. View is like, in order to get a result of your query which has been executed, and we use views for that. Then setting permissions on your tables, procedure and views. What is a procedure? What is a permission level we are talking about here? Who can access the ones which you have created? Now we have stored procedures, we have a views and so on, but who are the ones who can access them? So when you go back to any organization, as soon as you join in any of your roles, they will provide you a read-only access. Now that is a permission. Where are they providing? They're providing you for the database, where in a database level, in a server level, where you can access all the tables you have within the database. Now, when you're trying to give it with respect to your server level, you will have all the databases present between in that server. If they give you the permission with respect to the database, you will only have access until that database and nothing else. If they give permissions only with respect to that view, you will only be able to see the view and you cannot do anything else. Now, these are the main kind of the differences you will see when it comes to your permission level, and all these details will be handed by the admin, which is your DBA administrator. Let's see a little small syntax when it comes to your SQL. This is select customer name, city, country from customer, where the country is equal to USA. So this is a small syntax. It says that where the customer country is USA. So within my customer table, if my country is equal to USA, pull all the records from it. So select is a select clause. This entire stuff would be a statement. And then you will have your column names like customer name, city name, country name. And they are coming from clause. From which table they are coming from? They are coming from a customer table. So a table name, and then another condition where says where my country is equal to USA, which is used as a where clause. Now this is a very simplistic example. We are looking at it right here. Then now we define few things in your SQL with respect to your commands, with respect to your different kind of language options you can see. So if at all you're looking at it, we have a DDL, a DML, a DCL, and a DQL. So when it comes to your DDL, which is your data definition language, what it can do is it can change the entire structure of a table. It can change the entire structure of a table if you are using a DDL, which is your data definition language. How can it change the entire structure of a table? It can create a table. It can delete the table. It can alter a table and so on. Drop is also a delete. All right. So this is what your DDL can do. Let me reiterate it. DDL can change the entire structure of a table. Now I want you to assume in a class where you have a class HR stating that all these tables has to be moved as his wish. So DDL is like your HR now, and he tells which of those tables should be deleted from the entire class or which of them should be altered, like joining two tables or something like that, or you're adding few more people to it in that particular table and then creating new tables. Let's just by bringing new tables from a different class. All right. And not to forget, truncating is also comes under this. Now, let's talk about the data manipulation language, DML. Now, this DML, this is used to modify the database. This is used to modify the database. Now, this is responsible for all form changes in your databases like inserting, updating, and deleting as well. Now, Sai, you said already deleting in DDL as well, but you're again reiterating on the delete here. There is a difference between these two. When I say drop, it will drop the entire table. Let us suppose you have a three people sitting in a bench. Now you said drop the table. Now all those three people who used to sit on that bench, we can no longer be able to sit because you dropped the table out of your class. You you just removed it. But when I say delete, I'm only deleting the records. Now I have a bench. I have three people sitting in it. Now my class HR says I don't want one person to sit in that particular bench. So he removes that person. He deletes that person out of the class. He sends him just out of the class. Now that is data manipulation. Inserting new records, updating the records and deleting the records. We have to do nothing with respect to your tables. Now that is your data manipulation language. Now when it comes to your data controlling language, now these commands are like, they used to grant and take back the authorities from any users. Meaning, I provided you some permissions to have an access to a database. Now I say you cannot have an access to the database anymore, so you have to revoke the access. Meaning, you're just removing the permissions to which you have applied for the user. And then data querying languages. Now, data querying language is your fetching data from the database. Now, this is what we will focus on in the session. Because creating a table, altering a table, or dropping a table is all about your database administrator part. Inserting them, updating them, deleting them is also about your database administrator will take care of it. Your control language, which is your granting access and revoking the access, will also be taken care by the DBMS team. Data query language, even they can also help us with this or they may not. However, this is something which we have to focus on because we don't have to provide any permissions for any users that is out of our skill. We don't have to insert any records. We just have to read whatever it is present in the table. We don't have to create new tables because that's not required for us. We only have to read what is available within the database. Now let's see some important commands here like select statement. It will help us in extracting the data from your database. Updating will update the data in your database. Deleting the data from your database. Inserting a new data. Create database. It will create a new database. Altering the database. It will modify the database. Creating a table creates a new table. Altering table, modifying a table. Dropping a table, deleting a table. Create index, creates an index like a search key. Dropping an index, it will delete an index. Now, out of all this, there is something which we'll work on is select statement. But when it comes to your SQL, even like your Power BI, every column has its own data type. So while creating these new tables, while creating a columns within these tables, they have to provide the data type for them. Like string data type. You see the text here, it's similar to the text we have seen in our Power BI as a data type. So there are a lot of similarities and we will see all of these in detail. So when it comes to your character as a string data type, now this character, this is like a fixed length. It's like a fixed string. Now you have a lot of data coming in on a column as a text data type, correct? Now your character can contain any letters. It can contains any numbers and also the special characters as well. If at all you're using a character as a data type. But everything will have a length, isn't it? What is the length of it? 0 to 255 is the length of a character data type. Then you have nchar. Now, like similar to your character data type, your nchar is having n kind of characters. You can just enter n number of characters when you're choosing your nchar. And then text data type. Now this text is like it can hold a maximum length of 65,535 bytes. When you choose a text kind of a data type, 65,535 for your text. Similarly, your varchar can also do the same. So it can also contain letters, numbers, and also the special characters too. When it comes to your varchar, it can also have a column length coming from 0 to 65,535 bytes. And when it comes to your n varchar, it can have n numbers of length. So always choose, if at all we know like what is the text string which will be the maximum in that column. If you say that I don't think we will have anything more than 255 after you write everything, then that's good. But imagine, what about the comments? People write a very huge comments. So such kind of comments will require a lot of space. And we use nvarchar for that. Next, your numeric data types. Now your numeric data types like a numeric one. So numeric is all about having numbers in between them and bits. Now, in case if you remember your computer kind of a language when it comes to your bits. Now this is like it can hold values up to 1 to 64. in a bit. And integers, and again we will also have small ints in as well, but when it comes to your integer size, the range is so huge when it comes to your integer. There are a couple of things when it comes to your integer. There is a signed range and there is also an unsigned range. Signed range goes from your negative value to a positive value. I will tell you one value, you have to add a minus to that for a negative value, which is 214,748,3647 is going to be your signed range positive side. And when it comes to your negative, just add minus to it. It's the same signed range. But when it comes to your unsigned range of your same integer, the range is falling from 0 to 429,496, 7295. So that is where you will see the unsigned range, meaning it doesn't have any negative values. It will only have your positive values only. So the maximum display width it can have in an integer size is 255 only, which is 255. So the maximum display width it can have. And apart from that, we also have um, big ints, correct? So big int is again so huge rather than what I just told to your integer. And the signed and unsigned ranges also follow for your big ints too. And then when it comes to your decimal pointer, now we always have this fixed point numbers, right? Like point 0.2, point 0.3, point 0.4, and so on. So the maximum size for this is 65 for your decimal range. And the default value, if you are not providing anything for your decimal, is always 10. All right. That is for your size. Size is 10. And then float, right? Float is again, it is like you have your floating point numbers, right? Now, imagine your floating point values coming from 0 to 24. And when you try to go with your floating values for that, and it will come towards 25 to 53. So the data type will always become double when you're using a floater point on that particular column. See, it is not required you to have a lot more detail when it comes to your data types, but having at least a minimalistic information with respect to what it says about and why is it used is all we need. Because we are not going to define the data types in any of your tables, correct? We are just trying to go back and use them. So this is just a glimpse upon understanding what they deal with. So when it comes to your date, so date is again the similar kind of stuff, and the way it stores is 4 Ys hyphen 2M hyphen 2Ds. So that's how the format is for your date. And the range which is supported from is like you'll see, right? In most of the sites, it will be like uh, from your 1990, correct? This is not how it works in your SQL. It works like 1000 0101 to 999901 no not 01 9999 to 12th of like December of 31st, which means 9999 year December 31st, and the starting date is 1000th year 1st of January. So that is the range. You can just imagine when I say that. And then when it comes to your time, yes, it supports time as well. And the time will be stored in the way you already knew, like hours, minutes, and seconds. So when it comes to your time, the range is a little different here. The range of a time is you would think like we will have 23 hours for 59 minutes and 59 seconds, correct? So the time range, the way it is stored in your SQL is a little different. It is from negative to your positive side, which is my minus 838 hours of 59 minutes 56 seconds to 838 minutes of 59 minutes and 59 seconds. So yes, these are tricky to remember as well. I understand, but don't worry. We will just use whatever we have in your data type as a column. Next, we have date time. Yes, date time will also store the combination of your date and time, which is 4 Ys hyphen 2 Ms and 2 dates along with space after 2 dates space 2 hours like hours, minutes, and seconds. So that's how it will store the date time. And yes, we also have some timestamp. The difference between your date time and timestamp is date time does not have the UTC, the universal time uh, coordination or the condition. We say, right, whenever I ask you what is your time, they'll say like plus 5:30 IST, correct? So those kind of conditions are falling under a timestamp. So I will tell you one timestamp example, which is like 2022. So what's today's date? Like 28th February, right? So yeah, 0 to 28 space. The time is gonna be 5, right? So I'll say 17 is to 06 is to 01 seconds. And after that, it is IST, meaning it tells us that we are in this current time zone. So that is the only way you store it in your this thing. All right. And then we have the binary data types, right? So in case if at all you're looking for your binary data types, so what your binary data type does is the width of your binary string is gonna be up to 8,000 bytes. Verbinary will also have the same width, 8,000 bytes. And when it comes to your verbinary maximum, this is just 2 GB. So maximum it can store is like 2 GB when it comes to your binary data types and all. So this is how we are gonna use these data type particularly to fetch the details and to store them within your server. Then let's come to your joins, which is something which you all are aware of. Now your SQL join is divided into two different types, outer joins and an inner join. Coming to your outer join, we have a left join, righter join, and a full outer join. So let's see these joins one after the other. Let's start with the first one, which is your inner join. So when it comes to your inner join, now you have a table A and a table B. When you try to use your inner joins, it can return the records which will have all your matching values in both the tables. So only the matching records will be thrown at you when you use an inner join, no matter what. So left outer join. So this is your left outer join, right? So left join will be under outer and which is one of your SQL joins. So left outer join. So when it comes to your left outer join, it will return all your records from the left table and then it will throw all the matching records from your right table. So only the matching ones, as you all know. Still, let me reiterate. So your writer join will throw like it will return all your records from the right table and it will return all the matching records from your left table. Yes. When I say full join, no matter whatever the match is, it will just bring everything from both your tables. Now, let's talk it in terms of Power BI when it comes to your SQL, because that is what we will see. We will see a lot of queries in your SQL, and at the end, we will also see few setting options where we can connect our server to your Power BI as well. Yes, we all did this. We know how to configure a gateway. We know how to bring it to your database, configuring it, toggling your actions, connecting these connections, and then applying all these settings with respect to your Power BI gateway, because these details mostly should be handled by us as a Power BI admin or as a Power BI developer as well. So, but where do we write the query? We write it in terms of your SQL server, correct? So within your Power BI is where you write your query. Before we even write this query, we have to understand if we have the right tools required for it to understand that kind of the data being fetched from the server, from your database, from the tables, for which we will use a SQL Server Management Studio as a tool to connect to our server and then execute the queries we are looking after. So it all depends upon the query languages, the data query language DQL, which is one of the SQL command. Select statement. We will see a lot of select statements with respect to this, and we will discuss about mostly what all your queries we have. So this is just a small kind of an example which you are looking at, and we will see a huge queries, subqueries, having views, having, you know, um, creating multiple tables, or let us suppose if at all we have to create your SQL databases, or let us suppose imagine we are trying to connect with one of your joins using your left outer join. How do you do it in a SQL, and how do you do it when it comes to your trying to retrieve the data from your tables by using your aggregate functions, by using your queries on multiple tables with the help of your SQL joins, doing some subqueries, doing a similar kind of a filter conditions with respect to using your where, and how do we sort them, and writing uh, unions and having some views and so on. So we will see a lot of tasks coming within these. We will see a lot of exercises when it comes to your each of these data. We'll straight away start off by writing the queries using the SQL Server Management Studios. Like we have provided the Power BI handbook, we will also provide a handbook for your SQL queries with the queries with some exercises which we will deal about, and few exercises will be a task for you guys on that particular day. So the duration which we are planning for your SQL course is gonna be somewhere around like 2 weeks of time, which is like your 15-day of a course. It all helps us in understanding how to query the data from a database and bring it to your Power BI, create new reports. If there is something which you would like to add it in your query, what is that and how you do it? So multiple things we will perform with respect to your Power BI, keeping your Power BI in mind along with your SQL DQL as well, which is your select statements. All right. So with this, I'll pause here to see if you guys have any questions. If not, let's call it a day, and we will start the regular sessions from Wednesday. All right, a day's time to see about what's being preached here, and then you can also see what's happening. All right, so I will pause here to see if you have any questions. All right, so in case that if at all you would like to take up the sessions, you know whom to approach with. You can approach either Pramod or me to discuss anything further. All right, so let's call it a day. Bye guys, take care.